Good afternoon, my YouTube viewers. It is Crystal here. I'm just here this afternoon because I wanted to give you another code review. In this code review, I'm going to discuss 4 ways to do a linear model in Python. And so you're going to get the linear model, how to do it in NumPy, how to do it in SciPy, how to do it in scikit-learn, and how to do it in stats models. So there's 4 libraries that you can use to do a linear model. And that's what we're going to cover in this code review. So the first thing we're going to do is we're going to create our own data set. So the column that says family, we're just going to create a number from 1 to 40. The column that says salary, we're going to create a random intervals from random number from 10 to 100 because the salary is in thousands. The column that says home ownership, that's going to be based on if the salary is greater than 30, then own equals 1, else own equals 0. So if the salary is less than 30, then own equals 0, which if it's a 1, it means they own their own home. If it's a 0, it means they don't own their own home. And then we're going to create the data frame, and we're going to create the data frame by putting these 3 columns together in the data frame. So you can see here's the data frame that we have created. We're going to use the describe, so you can describe the data frame. So you can see it's got 40 elements in it, or 40 rows of data. The mean is 20, and it tells you about the mean for each row of data. It tells you about the standard deviation for each row of data, the minimum for each row of data, the 25 percentile for each row of data, the 50 percentile from each row of data, 75 percentile of each row of data, and the maximum for each row of data. So now what we're going to do is we're going to show you how to do linear regression in NumPy. So we have to import NumPy as NP, import matplotlib.pyplot as PLT. So model equals np.polyfit. X is going to be 0 to 39. Y is going to be 0 to 39. And it's going to be in one number increments. And then I did another one because I wasn't sure exactly how to do it, but M, B, SSE, then star underscore equals np.polyfit x, y, degree equals 1, full equals true. So that was just another one that I did. So we can plot a scatter plots using matplotlib. And then, so we plotted our scatter plot, and you can see the slope is 0.14, the intercept is 0.13, and the SSE is 3.155. So that is how you do linear regression in NumPy, and so you predict on it. So predict equals np.poly1d model, and so we're going to predict on the last element. And so when we predict of x, so when we predicted on the last element of x, it's going to be 0.57. Now we're going to create a linear model in SciPy, which is a scientific library in Python, whereas I didn't say that NumPy is a numerical library in Python. So with SciPy, we're going to import scipy.stats as stats, result equals stats.linregress, and x is going to be 0 to 39, y is going to be 0 to 39, and then you're going to print the intercept and then the intercept standard deviation. And then so the intercept is 0.29. 0.888. And then the intercept standard deviation is 0.0997. And now what we're going to do is we're going to fit the model. So x equals PD dot series x, y equals PD dot series y. That's in pentas. So we're going to fit our linear regression model, B1, B0, R value, P value, STD, ERR equals stats.linregress, and then X, the first 39 elements of the data frame, and Y, the first 39 elements of the data frame. So we're going to make predictions on that. Y hat equals B0 plus B1 times X to the last element of the data frame. And then y hat is 0.57. So you can see over here with NumPy, the prediction is 0.57 as well. So you can see that the prediction is the same on the last one. And you can see it says 39. But remember that in Python, the first number starts with 0. We're going to plot it on a graph, and so you can see on a graph that this is binary, so it's either going to be 0 or 1, as it was binary when we were using NumPy. It was either 0 or 1. Now we're going to predict on the linear model using sklearn. So we're going to import pandas as PD from sklearn.linearModel import linear regression. So x equals PD dot data frame x, y equals PD dot data frame y, reg equals linear regression dot fit x the first 0 to 39 or 0 to 38 weekly, and y 0 to 38. Print the score is 62% accuracy. Print the coefficient, and then print your intercept. So your intercept is 0.298881. So let's see if we can find out what the intercept is here. 0.298881. So you get the same intercept. So now we're going to predict on it. We're going to predict on the last element of the data frame and YPRED, and it's going to be 0.57. And you can see our Y hat here is 0.57. So, and then we plotted it using Matplotlib, and you can see it's the same. It's either a 0 or a 1. And so you can see that if the x variable is greater than 30, it's a 1, and if it's less than 30, it's a 0, and it shows you that on the plot. So now what we're going to do is we're going to use linear model using stats models, which is a statistical library. And then in order to get the intercept to work, we had to create an extra column and call it intercept. So y equals dfy, x equals df intercept comma x. Model equals sm.ols. Y is 0 to 39 and x is 0 to 39. And the results equals model.fit, print result summary. So you can see a summary with stats models, and you can see that the intercept is 0.0299. So let's see what we've got here. Hmm. 0.0299. So it's the same in stats models as well. And then so we're going to make predictions on this. So results equals predict the last element, and it's going to be 39 is 0.57. So you can see that the prediction is 0.57, so that's correct. And you can see that when we trained and fitted the model, it was 0 to 39 for your X and your Y. So you can see on all of these 4 methods that we use to make predictions using linear regression, you can see all 4 of those. We use the first 39 rows of the data frame, and then we made predictions on the last row of the data frame. And the reason why you had to do that is because in machine learning, you cannot predict on data that you have trained and fitted. You have to predict on all new data. And since I only had like maybe 40 columns of data, 40 rows of data, I could only predict on one element. But let's say, hypothetically, we had 400 rows of data, which we could do that. Then we could say the what we were going to train and fit the model would be on 0 to 390, and then we could predict on 10. So that's something else that we can do to check on our predictions. And then another thing that we could do is we could compare the actual values to the predicted values. So that's another thing that we could do. But I didn't do it in this instance. I just predicted on one element of data, and on all 4 methods that we use to run the linear model, the prediction all turned out the same. And for the most part, the intercept turned out the same as well. So we can check the intercept just to be sure. So the intercept for this one was negative 0.013, and but for the second one with SciPy, it's negative 0.2988. For sklearn, it's negative 0.02988. And for sklearn, for stats model, the intercept, the coefficient was 0.299. So on the NumPy, for some reason, we didn't get the same intercept, and I'm not sure exactly why that is, but you did actually get the same prediction on all 4, and on all 3 you got the same intercept as well. So that was a pretty good outcome, and I just wanted to show you 4 ways that you can use a linear model in Python, because primarily I use sklearn, and sometimes I use stats models, but very rarely do I use NumPy or SciPy. So it was just nice to research this and find other ways to use a linear model. So if for some reason you don't have access to stats models, but you do have access to NumPy, you can always use NumPy. And NumPy takes you closer to home because it takes you closer to home, and especially SciPy takes you closer to home because y hat equals b0 plus b1 times x. So I'm going to go ahead and close this video because I've covered everything that I would like to cover. I would like to thank you for watching my video. If you like my video, please like, subscribe, and share. And I would like to thank all of my subscribers for supporting my channel. I look forward to making more code reviews for you in the future.